Hey, 8th grade. So our learning target today is I can simplify square root expressions. You should be on page 8. All right, so what are we talking about today? We're talking about square roots. We've been talking about square roots for the last couple days. Remember, square root is the opposite of area. So if we have a square that has an area of 9, when we take the square root of 9, we really want to know what is the side length of the square. It's 3. So this symbol means what is the side length of the square. The side length of that square is 3. Okay, so that's what a square root does. So how do we simplify square root? Step 1, we find the biggest perfect square factor. We'll talk about that as we work today. So we're really going to do our perfect squares, the ones that we really like, the rational number ones. And then step 2, we simplify. So this is going to feel a little bit like a factor tree to you, those of you that are comfortable with prime factorization. It is not prime factorization, but that might be kind of how it feels to you. So we have this property that says if we have a square root, we can split them into factors. We can split it up into the square root of a times the square root of b. We can kind of pull it apart through operation of multiplication. We are going to use our cheat sheet over here. These are the perfect squares, 1, 4, 9, 16, because when you take the square root of them, they come out to these nice whole numbers. Those are the rational numbers. So the square root of 20, we want to know what does that break into. We're looking in this cheat sheet over here to see if can we pull out any of these numbers. So is there any numbers that go into 20 that's in this set? You would say, well, 4 does. So we're going to take the square root of 4 and break it into square root 4 times square root 5. Notice I put a multiplication dot in between there. Now this is not a factor tree, but it's going to feel like that. We're going to simplify to get all the perfect squares reduced. So we take the square root of 4. Remember, that's just a square that has the area of 4. That symbol means what's the side of it. It's 2. Square root 5 is not in that list. The square root of 5 is in between there. That's an irrational number, so there's our answer. 2 times square root 5. Looks weird, feels weird, but that's our answer. This is called simplifying square roots. Okay, our next example is the square root 90. So we're going to go back to our cheat sheet and ask, is there anything in this perfect square list that we can pull out of 90? So I'm scanning this list of numbers. Is there anything in there that I can pull out of 90? What goes into 90? Well, I see a 9, and I know that will work. So we have the square root of 9 multiplied by the square root of 10. That makes 90. And the square root of 9, remember that's the square that has the area of 9. That symbol means what's the side of that square. That's a 3. It's 3. So we have 3 square root 10 left. So now 3 is done. That's a whole number. Square root 10. Is there anything over here in this list that we can use for the square root of 10? We know 1 works, but 1 doesn't help us in this work. Does 4 go into 10? No. Does 9 go into 10? No. And the rest are too big. So we are done. The final answer to this problem is 3 times the square root of 10. Looks ugly, but that is as far as we can go. So next we have square root 45. As we look for the square root of 45, we want to know, do any of these numbers go into 45? 1 does, but not helpful. We're wondering, does 4 go into 45? No. Does 9 go into 45? Yes. The square root of 9 does go into 45. And we're thinking, well, what times 9 gives us 45? 9 times 5 gives us 45. So we have square root 9 times square root 5. The square root of 9 is a square that has an area of 9. What's the side of the square? The side of that square is 3. So we have 3 times square root 5 then. And we're thinking about square root 5. If I look over the list of numbers here, square root 5, do any of them go in there? Well, 1 does, not helpful. 5 is an irrational, icky decimal. Done. 3 square root 5. Next problem is we're going to switch it up a little bit. We've not done this much. Next problem we have, we're going to split up the variable parts and the numerical parts. So I'm going to split this using the property up here that says we can split these up. I'm going to split it into the square root of 144 times the square root of x squared. Because that property up here allows us to do that. Okay, square root of 144 is right here. That means there's a square that has the area of 144. What's the side of that square? It's 12. So that one's done. And when we do this property here, squaring and square rooting are opposites. So just an x drops out here. So my final answer is just 12x. Nothing I can do here. Can't find x unless somebody tells me what it is. It's just an expression, 12x lowest terms. Next problem. For this next problem, we have 5 multiplied by the square root of 18. So we have 5 times, and I'm going to try to break that up. Square root of 18, wondering what goes into 18. Well, I know 9 does. So that becomes the square root 9 multiplied by the square root 2. That makes an 18. So I'm working left to right. We have 5 times. Square root 9 is 3. And the square root 2 is an irrational number. We cannot find to make a square that has an area of 2. Okay, so now cleaning this up. Combine like terms, 5 times 3, that's on the outside of the parenthesis, we can do that, is 15. And the square root 2 is still an irrational number. So my final answer here is 15 square root 2. Final answer right here. Okay, and moving on. So next problem, we have negative 2 multiplied by the square root of 50. Looking in the list of numbers, let's see what we can come up with. So we have this negative 2 on the outside, no problem there. We're just going to use that as multiplication, negative 2 times. And then we're going to break this tree apart here, square root of 50. So for the square root of 50, we're going to pull it apart as the square root of 25 times the square root of 2. Square root of 25 times square root of 2. As I start to solve them, if I haven't used it, I drag it down. And the square root of 25 is 5. And if I haven't used it, drag it down. So we have negative 2 times 5, square root of 2. Combine like terms at this point. Go ahead and multiply these out. So we have negative 2 times 5 here on the outside. Combine like terms, which is negative 10. If we haven't used it, drag it down. Final answer is negative 2 times square root of 10. Or, pardon me, negative 10 times square root of 2. I messed it up. Sorry, guys. Negative 10 times square root of 2. Okay, those are product properties, so multiplication properties. I gave you 6 examples up there. You're kind of doing it like a tree diagram, but we're really looking for perfect square roots. Using this cheat sheet over here is super helpful. All right, moving on. Quotient properties now. I'm going to slide this down with me. Quotient means division, so same property where we can break it up the same type of way. All right. Trying to get that all on one screen. There we go. So quotient properties say that I can give the square root to the top and I can give it to the bottom, so we can break it apart. So as I do that, I end up with the square root of 6 on top and I end up with the square root of 9 on the bottom. Looking at the square root of 6, I'm wondering, is there any way to break this apart, the square root of 6? Well, 1 goes in there, but that doesn't help us. 4 does not go in there. 9 does not go in there. So we're kind of done. We just have square root of 6 on the top. In the bottom, the square root of 9 is perfect. It's 3. Square root of 9 is 3. So there's my final answer. It's the square root of 6 on top and a whole number 3 on the bottom. Looks weird, but that is simplified in 8th grade. Actually, anywhere it's simplified. There's some rules, though. We can't leave a square root on the bottom as we proceed through our math career. But in 8th grade specifically, then we would be in lowest terms on questions like that. All right, next problem. Give that distributed property idea to the top and the bottom. Gives us the square root of 75 on top. We have the square root of 100 on the bottom. We're going to go ahead and clean this up. We want to know what goes into 75. Well, I know 25 does. So I know 25 cents. 3 of them make 75 cents. 3 25 cents. Okay, and then in the bottom, I have 100, and I know 25 cents goes into 100 as well. So I have 25 cents, and in the bottom then I have 4 of them. Okay, so here's what's left in the problem. Is there anything I can clean up? Well, I know the square root of 25 is 5 times square root of 3 still on the top. And on the bottom, I have square root of 25, which is a 5. Because 5 times 5 makes 25, right? Is that perfect square that's coming from this one? And a square root of 4 on the bottom. So we have a 5 divided by 5 is 1. So my final answer in 8th grade, this is a question where as you proceed through math, you would have another way to solve that, is just the square root of 3 over the square root of 4. Now, some of you might be like, wait, Ms. Volkman, that doesn't make sense with what you just did because, and I did this on purpose, you might be thinking, wait a minute, square root of 4 is on the bottom. Is that simplified all the way? Is there any way to possibly reduce that square root of 4? Yeah, the square root of 4 is 2. So we could reduce that to a 2. So my final answer to this problem way up here was the square root of 3 over 2. There is our final answer. So sometimes we don't even realize there's another factor available in there. You think we're done. And right here, I didn't notice it in this step, but that's okay. You can catch it in that step as long as you catch it somewhere before your final answer. All right, moving on to this box over here. We're going to give that square root to the top, and we're going to give it to the bottom. So that becomes the square root of 7 on top and the square root of x squared on the bottom. Square root of 7 on top. In the bottom, we have square root x squared, noting that square rooting and squaring cancel, and we get just an x on the bottom. The square root of 7 on top, that's just an irrational number. It's actually a prime number as well, so only 1 and 7 go into it. 1's on the list, not helpful, but 7 is not, so we're done. There's our final answer. Square root 7, sorry about my mess here. Square root 7 on top, x on the bottom, final answer. All right. And cleaning this last problem up. I'm kind of out of space here, so I'm going to maybe drag this problem down with me. So this is the problem from this box. I just ran out of space. Okay, so we're going to give that square root to the top and give it to the bottom. We get the square root of x squared on top, and we get the square root of 80 on the bottom. When I solve that, the square root of x squared on top, the square and the root cancel gives me x. Square root of 80 on the bottom. When I break that apart, 80. What goes into 80? Well, let's see. 4 maybe does, but for sure I know 9 goes into 80 because I know 9 goes into 18. Oh no, 9 doesn't go into 80. Whoops, what am I thinking? Does 4 go into 80? Yeah, 4 goes into 80. So 4 goes into 80 how many times? 20 times. 4 goes into 80 20 times. You might need your calculator for that. I don't know what I was thinking there, but sorry about that. So we've squared 4 times squared 80. We're going to break it apart again. Squared 4 is a really nice number. Whoops. Oh, man. I'm backing up here. Sorry, guys, about this. Let me start over. Square root 80. I'm going to pull a 4 out of that right here, this 4. So we have square root 4 times square root 20. Sorry about all my mistakes here. That's what happens when you're 12 minutes in a video. Here we go. Square root 4 is 2. And the square root of 20, can I break that apart? Is there anything that I can pull out of 20? Looking back at my cheat sheet, I could take out another 4. So we have square root 4 times square root 5 makes a 20. Cleaning the denominator up, then we have 2. If I haven't used it, drag it down. This is also a 2. And if I haven't used it, drag it down. So that becomes 4 square root 5. 4 square root 5 is on the bottom. So my final answer is x on top and 4 square root 5 on bottom. So our homework are for our summaries today. Remember, when simplifying, one of the square roots has to be a perfect square. So when you break up that tree diagram, you have to have one a perfect square. So what I mean by that, if you were breaking apart the square root of 18, when you split, one of these has to be a perfect square. So for example, the square root 9 would work. I don't think that color is going to show up on the screen. Square root 9 works. That's a perfect square. It's okay if the other one is not, as long as one of these comes out to be a perfect square. Okay? And be sure you simplify all the way. You'll notice on that one example, when I split it, I still had that square root 4 in the bottom. Make sure that you simplify all of them all the way. So that's your summary for today. Your homework for tonight is to just do page 9. Make sure you're looking at your cheat sheet. Make sure you're simplifying everything all the way. Have a fabulous night, 8th grade.